Instruments for measuring solar radiation. Let us discuss about the instruments used for measuring solar radiation. Shading analysis tools. These are the instruments which can access the site condition in terms of shadow analysis during effective sunshine period so that the place is not under shadow. The site analyzing products are Solar Pathfinder, Wiley Asset, and Solmetric Sun Eye. The pictures show the shading analysis tools which are used for measuring solar radiation. Solmetric Sun Eye instrument. The Solmetric Sun Eye instrument makes it possible to simulate this chart and get the view of the sun as it moves through the sky. This video will demonstrate how to utilize the Solmetric Sun Eye instrument. Now you are able to understand how to use the Sun Eye instrument. This collected data is transferable and adaptable for universal design software such as PV System and PV Solutions. Sun Path Finder. The Sun Path Finder is an instrument which makes it possible to simulate stereographic sun path chart and get the view of the sun as it moves through the sky. This video will demonstrate how to utilize the Sun Path Finder. Now, you also know how to use the Sun Path Finder. Separation between rows to avoid shadow. This slide gives the separation distance as a rule of thumb for fixed tilt solar installation at a time of altitude angle at 9 am or 3 pm. In case of fixed tilt collection system, optimum separation distance is equal to sine 0.87 degree latitude into panel length into cos 45 degree by tan altitude angle. True south. In the northern hemisphere, stationary PV arrays are oriented towards south to maximize the PV output. But using your compass to find south will only give you an indication of magnetic south, not true south. The difference in the orientation is called as magnetic declination. Depending upon the country, there is difference between the true south and magnetic south. This is not very significant under Indian condition, which is hardly 2 degrees. True north. In the southern hemisphere, stationary PV arrays are oriented towards north to maximize PV output. But using your compass to find north will only give you an indication of magnetic north, not true north. Usually, the magnetic declination should be either subtracted or added to your magnetic compass reading to find true north or true south. The declination is based on your latitude and longitude. The following link can be used to find the magnetic declination at any place. True south versus magnetic south. If the location is in the northern hemisphere, the panel should be placed facing south direction, and vice versa for proper orientation of the panel. For that, we need to understand about true south and true north. True south versus magnetic south. True south is the direction towards the southern end of the axis about which the Earth rotates, called the South Pole. The South Pole is located in Antarctica. Magnetic south is a direction towards the South Magnetic Pole, some distance away from the South Geographic Pole. True north versus magnetic north. True north is a direction towards the northern end of the axis about which the Earth rotates, called the North Pole. The North Pole is located in middle of Arctic region. Magnetic north is a direction towards the North Magnetic Pole, some distance away from the North Geographic Pole. The difference between true south and magnetic south is meager for India, varying between plus or minus 2%. India is located in northern hemisphere and the orientation should be in southern direction. This graph depicts that if the orientation is towards true south, tilting the object to optimum angle would make it able to collect maximum amount of energy. This slide depicts as what should be the separation factor with respect to the latitude for different times of energy collection period.